Hello everyone, welcome back to Calculus BC. This is lesson number 19 and this is going to be a lesson on trig substitution. So I want to do question number 9 in this video, just this one example, and then in the second video we'll do example number 10. But I want to say it's halfway through the packet because the majority of our packet, guys, is just review from the various integration techniques that we've learned in the past few videos, or past few lessons, I should say. So let's look at question number 9. Now, I'm going to write it over here that if we wanted to use u sub, right? So if we wanted to use u sub for this problem, it would be 1 minus 4x squared. Our derivative would be equal to negative 8x dx. So we can't use u sub because there's no x there. So I could essentially rewrite this problem like this, and then this would be the technique that you would use, right? But again, we're not going to use u sub here because there's no random x there. Well, the next thing we can look at is possibly arc sine, right? We have a square root of 1 minus 4x squared, but in order for arc sine to work, we would actually have to have it over a constant, right? 1 minus 4x squared dx. So even though these are good ideas, you cannot do this problem based on an arc sine or a u sub problem. So then we have to think about, oh yeah, this is probably an arc. This is a trig substitution problem, and this is exactly what this is. So let's go ahead and actually talk about how to do the trig substitution problem. Now, with these kind of problems, you should be thinking about some arc sine, arc theta, something like that. The fact that this is going to be the square root of 1 minus 4x squared, arc sine is a really good place to start. So you guys remember that from the formula, if we were to actually look at this, arc sine would be, remember, it's going to be the u divided by a. This is how we learned it, right? U is going to be 2x. A is going to be equal to 1. That's going to give us theta, right? So arc sine of 2x over 1 equals theta. So that tells me that sine of theta is going to be equal to 2x over 1. Okay, so 2x over 1. Now, why is that important? Well, let's go ahead and draw ourselves a triangle, a right triangle, and we're going to go ahead and we're going to put a theta here. And by the way, if any of you guys are confused about how I was able to get this, go back to lesson 17, I want to say video number 3, lesson 17, video number 3, and this, I can show you guys where this formula came from, okay? So we have arc of theta equals 2x over 1. So you guys have learned that we have a 2x here, right? This is the sine is going to be the opposite side over the hypotenuse. And then in order to find this side right here, we're going to actually just use Pythagorean Theorem. So 1 squared equals 2x quantity squared plus, and I'm going to call this a for right now, so this will be a squared. And then when you find out what a is, to save us a little bit of time, you're going to get that it's going to be the square root of 1 minus 4x squared, right? And so we now have ourselves a right triangle. So we used the fact that this is an arc sine function, and then we were able to rewrite this in terms of just what sine of theta is equal to, and then use the proportion of SOHCAHTOA to find our triangle. Now, this is why this is called trig substitution, because what we're going to do now is we're going to rewrite the square root of 1 minus 4x squared dx in terms of trig. Well, if you guys look at this triangle, the cosine of theta, right, the cosine of theta is going to be the adjacent side over 1. So this is actually going to be equal to cosine. So we can actually say that the square root of 1 minus 4x squared is equal to cosine of theta. Now, what we have to understand here is that dx, we got to solve for dx. Well, how do we solve for dx? Well, we have the formula, sine of theta is equal to 2x. Let's implicitly differentiate this, right? Let's implicitly differentiate this. So sine of theta is going to be equal to cosine theta d theta dx, and this is going to be equal to 2 dx. So dx is actually going to be equal to 1/2 cosine theta d theta dx. So we have to substitute, sorry, I just had to erase all that. So we had to substitute dx with 1/2 cosine theta d theta. So when we do this, we have now rewritten this as, and I'm going to go ahead and pull out the 1/2. I got 1/2 the integration of cosine squared theta d theta. Cosine of x d theta. Okay? And we have learned how to integrate this, again, back in lesson number 17. We learned that cosine squared theta is the same thing as 1 plus cosine of 2 theta all over 2 d theta. Okay, so we've learned how to do that based on our problem, and so let's continue on with this problem. So we're going to have 1/2. I'm going to go ahead and pull out the 1/4. I'm going to pull out the 1/2 to become 1/4, right? So I'm going to have 1 d theta plus 1/4 cosine of 2 theta d theta. Okay, so now 1/4, 1 d theta, that just becomes theta, right? So this just becomes theta, or, you know, whatever we're looking here. And then this guy right here, well, we're going to go ahead and remember that this is going to be, let's change the color up so we get a little bit of stuff here. So u sub is equal to 2 theta. So du is going to be equal to 2 d theta. So I have to pull out another 1/2. So 1/8. And then I'm integrating cosine of u du. So 1/4 theta is equal to 1/8. And again, we're going to integrate cosine. We're going to get sine of u. Well, let's just go ahead and write down what u is. It's just 2 theta plus c. All right, guys, so we're not completely finished with the question. So this is the idea, 1/4 theta plus 1/8 sine of 2 theta plus c. Remember that the question was in terms of x, right? So we have x's here. So we want to go ahead and rewrite our function in terms of x to get it back to where we were, just like with u substitution. So we know what theta is. We know theta is going to be the arc sine of 2x. Now, here is what I want to say about this. So for this theta, I'm going to go ahead and write that. So I'm going to write 1/4, and I'll do the arc sine of 2x. Awesome, 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 awesome. Plus 1/8. Now, I have sine of 2 theta, right? Sine of 2 theta. So what I want to do here is I want to rewrite this in terms of sine of 2 theta cosine theta, right? I'm going to go ahead and just use my double identity for this. Now, you could, yes, say that you want the sine of arc sine of 2x and the cosine of arc sine of 2x, but that becomes really, really complicated. So what you want to do here is we're going to do the 2, and we're going to find what sine of theta is. Well, we already know what sine of theta is. It's 2x. So instead of getting crazy with it, let's just write 2x. We also know what cosine of theta is, right? We learned that, right? It's the square root of 1 minus 4x squared. So this is going to be 1, what was cosine? I like my brain. The square root of 1 minus 4x squared. And then plus c. So you guys can see why this is incredibly complicated, but this is the way that you do the problem. And so just to simplify, our final answer to this problem is going to be 1/4 arc sine of 2x plus 1/4, actually another 2 right there, so it'd be 1/2, right? 1/2, because I got another 2 here. So 1/2 of x times the square root of 1 minus 4x squared plus c. And you guys can see why I'm doing this example in this video, because it took me about 10 minutes to do this particular problem. So that's how you use trig sub. A little craziness. I would suggest that if you guys want to go back and rewatch it if you need to, and to see my steps again, you can. And I will see you guys in the next video.